Hello friends, this is Deepak Kumar, Assistant Professor in KIET Group of Institution Ghaziabad. In this lecture, we will discuss the concept of 8086 pin diagram. So as I told you that when we are talking about 8086, then we just told you that here we have 40 pins, dual package of 8086. Out of which 20 pins are in left side and the remaining 20 pins are in right side. So, as I earlier told you that when we are talking about 8086, so 8086 actually operate in two modes, that is your minimum mode and maximum mode. I just told you that what is the meaning of this minimum mode and maximum mode. So when there is multi-processor environment, then 8086 will be considered as maximum mode, and when only we have single processor, that is 8086, then it is known as minimum mode. So actually if it is working in maximum mode, then we have some different pins. If we are working in minimum mode, then we have some different pins. So right now we are just discussing the pin diagram in maximum mode. Okay, how we will how the pins are actually operate in maximum mode, we will discuss on that. Okay, so we will start with the first pin, that is your VSS. VSS is basically used for ground supply. As we know that every microprocessor needs some power supply. So plus 5 volt power supply is required, and when we provide power supply, then we require ground signal also. So VSS is actually used for the ground purpose. Here we have total 20 address lines are there, AD0 to AD14, it is your 15 address line, and here we have AD15 to A19. So here we have total 20 pins are there for address as well as for address information. Out of these 20 lines, the 16 address informations are multiplexed. So that is from AD0 to AD14, then AD15. So AD0 to AD15, that means we have 15 address line which are multiplexed with the data. Okay, and now we have remaining 4 pins, that is A16, A17, A18 and A19, that are multiplexed with status signals, that is S3, S4, S5 and S6. I just discussed what is the meaning of this S3, S4, S5 and S6. That means it actually contains the address information A16, A17, A18, A19, or it will be considered as the status information. So now we will focus on that what is the meaning of this status information. If we are talking about S3 and S4, so what is the meaning of S3 and S4? S3 and S4 basically identify that in memory which segments we are just reading or writing. Okay, so read and write operations perform in which segment, it will actually identify via this S3 and S4 pin. Okay, so as we know that we have total 4 segments, 4 different types of segments in memory, that is code segment, data segment, stack segment and extra segment. So in which segment we are just working with, it's in extra segment, in stack segment, it is actually identified via S3 and S4 pin. When it is 00, then extra segments will be considered. When it is 01, then stack segment will be considered. When it is 10, then code segment will be considered. And when it is 11, then data segment will be considered. Okay, so that is actually the meaning of this S3 and S4 pin. Now, if we are talking about S6, so S6 pin remains always in logic 0. Always logic 0 means S6 status pin is actually reserved for future purpose. Okay, and it is always in logic 0. If you're talking about S5, so S5 basically tells the status of the microprocessor, that which modes we are actually working on. Okay, that is basically your S5 bit. Next one is your next bit is your NMI. If you are talking about non-maskable interrupt, so if there is a device that provides the non-maskable interrupt, then this request will be provided using NMI pin. Then we have INTR, so maskable interrupt will request with this particular pin, INTR. CLK, that is your clock signal. Clock pulse is basically used to synchronize the internal components of microprocessors, 8086 microprocessors. Okay, so these component synchronizations will be performed using using clock pulse. Then we have Vss ground signal. Again, this pin is basically used to perform grounding. VCC means power supply. So 40th pin will be used to perform or to provide the power supply. Now I had already discussed all these pins. Now the 34th pin is basically used for bus high enable purpose. Bus high enable purpose means actually in 8086 the size of data is of 16 bits, and this 16 bits information will be divided into two parts, that is the lower half part and upper half part. So this upper half part will be considered as data, or it will be considered as address. So this informations will be identified via bus high enable. That means if higher order 8 bits are enabled, then this value will be 0. Bus high enable value is 0. Why it is 0? Because bus high enable is your active low signal. So when it is 0, that means higher order 8 bits are enabled. Okay. So that is the meaning of bus high enable. And bus high enable is always used with A naught. Okay. If bus high enable and A naught is 0, 0, that means we are just reading the whole word. If it is 0, 1, that means only upper bytes are basically read or write. When it is 1, 0, that means lower byte are basically read or write. And when it is 1, 1, then that means there is no operations. So always remember that bus high enable pin is always used with conjunction A naught. Okay. So that is the meaning of bus high enable and S7. Mn/mx complement will tell us that 8086 is working in minimum mode or maximum mode. Okay. If it is 0, then it is working in maximum mode, and if it is 1, then it is working as a minimum mode. RD complement is basically used to perform read operations. RQ complement and GT complement, actually as I told you that if we have multiple processors, so multiple processors may request for accessing the data and sending the data. So which processor is actually requesting, or we are just granting the signal? So it depends upon these particular pin. So processor 1 will send the information with this particular pin, and processor 2 will send the information with this particular pin. Okay. So request and grant signal will be performed via this particular pin. Okay, lock is basically used that, let's suppose if we have multiple processor, and out of these multiple processor, one processor is accessing the control of the buses. So the remaining one, and when the one processor accesses the control of the buses, then it basically lock itself, so that the other processor cannot use these particular buses. So for this lock pins are basically used. S0, S1 and S2 is basically used to tell the status. So it basically tells that this is your input output read or input output write, or there is an interrupt acknowledgement, or there is halt signal. Okay, when it is 100, then it means that there is opcode fetch. When it is 101, then we have memory read. When it is 110, then we have memory write. And when it has 111, then it shows that we have passive operation. That means no operations are performed. So that is the meaning of these three pins, which tells the status of the operations of 8086 microprocessor. So these pins are also clear, S0, S1 and S2. Okay, these two pins, QS0 and QS1, is basically tells the status of queue, prefetch queue, that I have discussed in our architecture of 8086. So what is the meaning of QS0 and QS1? When QS0 and QS1 is equal to 00, then no operation is performed. When it is 01, that means first byte of OP code from the queue. As I told you that here we have queue which prefetch at most 6 bytes of information. So 1, 2, 3, 4, 5, it basically prefetches 6 bytes of information. That is your queue. So if the QS0 and QS1 is equal to 01, that means first byte of OP code from the queue is fetched. That means this first byte of information is moved towards the control unit. Okay, that is the meaning of this one. 10 means empty the queue. That means all the queue is basically empty. Okay, 11 is basically tells us that subsequent byte from the queues are transferred. So if it is 01, that it is first byte is transferred, and if it is 11, that means subsequent bytes from the queues are transferred. Okay, so it basically tells the status of 8086 queue. Okay, now the next one is your test pin. Test pin is basically used with the help of wait signal. Actually, when wait signal is activated, then microprocessor 8086 microprocessors just move towards the waiting condition. So this will remain in waiting condition until or unless this test complement value is 0. That means until or unless this pin is not activated, then till then microprocessor will be in waiting conditions. Okay. So now the next one is your ready signal. So ready signal is basically tells the peripheral devices or the external devices that the microprocessor is ready to perform communication. Reset pin is basically used to reset the hardware of 8086 microprocessor. So when we are resetting the microprocessor, that means there is no operations is performed. That means whatever the current operations, whatever the present operations, that will reset its executions. And it will remain reset until 4 clock cycles. So that is actually the meaning of reset operations. So these are the meaning of all the pins of 8086 in maximum. Okay. So in our next lecture we will discuss the pin, the functioning of each pin of minimum. Okay. So these are the references. Thank you so much.